In this problem, we're told that the table gives the height h in feet of a golf ball t seconds after being hit. So my input is my first column here, and the input quantity is time. So we're going to write that here. Input variable is t, and the units are seconds. So all of those are very important to include and understand. The output quantity, that's my second column. The output quantity is height. The output variable is h, and the output units are feet. Now, to write the data as a set of ordered pairs, what we're going to do is use what is called set notation, which has these little squirrely brackets, and then we are going to write each of the ordered pairs and include them in the set. I'm going to do that. You go ahead and do that on your paper, and when I come back, we'll check and see if you have the same results that I do. So writing out the data as a set of ordered pairs just gives us another way to visualize the information that we were given. So your data set should look like mine. The kind of curly Q brackets are important, including the ordered pairs is important, and the notation with commas is important because what we're saying is that each of these ordered pairs is an element of this particular set. Now, part D, interpret the meaning of the ordered pair 3, 144 in the context of this problem. So remember, our input is time and our output is height. So what we can do here is to say that after 3 seconds, that's our time, and our situation is that we have a golf ball being hit. So the golf ball is 144 feet high. In part E, we're asked, is height of the golf ball, the given golf ball, as represented in the table a function of time? Why or why not? So height is my output, as I see in the table. Time is my input. So is height a function of time? In other words, for each time value, is it assigned to a unique value for height? So if I look at my inputs for time, they are all unique. They are predictable. I can use the chart here to predict if time is 1 second, height is 80 feet. If time is 4 seconds, height is 128 feet. So yes, and the way that I write that, just to kind of use the formal definition of a function, is that each time input is assigned a single unique height output. Because remember, what's important when we look at a data set to help us understand if it represents a function is whether or not we can use that data set to predict, given an input, the output that is associated with it. In other words, we cannot have two choices for the output for any given input. So let's look at part F here, and what they're asking us is seconds after being hit, so time here, a function of height. So what they're asking us to do is to switch the order of the input and the output in the table that we were given. I'm going to do that on my paper and then come back and then we'll talk about it. So what we're asked again here is to determine if time is a function of height as presented with the data in the table. And you can see what I've done here is to rewrite the order. Height is now input, time is output. If I look down at my values for height, I see I have two of them here, two situations where I have a height of 80 and an output. The outputs are different. If the outputs were the same, we'd be okay. But because I have 80 being assigned to an output of 1 and 80 also being assigned to an output of 5, I cannot use these data to predict for outputs, for inputs what the outputs are. So I'm going to have to say that no, time is not a function of height for this data set. And in general, that will be true, that time is not a function of height. There may be some isolated data sets where you can create a function given a particular data set with a relationship between height and time, but in general, time is not a function of height as illustrated by this example.